Okay, we will go to the next step. Okay, so that is generating a line coded signal. Okay, so we have the random bit stream. Okay, so this is the random bit stream. So it represents our message signal. Okay, so excuse me. Okay, so this will be our message signal. Okay, so you already know that this is a array. Okay, so here we have 20 columns. So this is the array 1 into 20 array. So that means we have 1 row and 20 column. Okay, so 20 column means we have 20 bits. Okay, so actually this is the index of the matrix of that component. Okay, so these are the components 0 0 1 1. Okay, these are the index of the component. Okay, so if you want to read a component, okay, let's say that you want to get the first component of this array. Okay, so you can simply type, so our matrix is M. Okay, so we defined our matrix, sorry, we defined our array as M. Okay, message signal. Okay, so you can write sorry, brackets 1. Okay, so you will get the first component. Okay, 0. Okay, if you want to read the fourth component, you can simply write like this. Okay, and if you want to let's say that you want to read uh, so this index also you can define as a variable. Okay, for example, you can define it as I or something. So let's say that I equal to 1. Okay, so if I get M I, okay, so then I will get the again the first value. Okay, so here I use this index as a variable. Okay, so likewise you can read any component of this array. Okay, of array. Okay, so it is stuck, as I can see. Okay, anyway, I will get a new document. Okay, sorry. I think it is okay. Okay, so so here now we have our bit history. It is like this. Okay, like this, and then bit history. Okay, so this will be our first bit. Okay, so this will be our first bit, this will be our second bit, so on. Okay, so this is our message. Okay, then this is just value. Actually these are numbers, 0 and 1, just a number, binary sequence. Okay, so we need to convert them into a electrical signal. Okay, so we need to convert them into a electrical signal, so that we are using line code. Okay, line code, sometimes called encoder. Okay, anything. Okay, so here here using this line coder or using a line coding technique, you just assign some value, some voltage value to 0 and 1 for a certain time duration. That is very important. For a certain time duration, we assign a voltage value. Okay, so let's say for 0 0 volt, for 1 we assign 5 volt, likewise. Okay, so for a certain time duration, let's say the time duration is t1. Okay, So actually this is NRZ, okay, non-return to zero unipolar line coding technique, okay. So there are many line coding techniques available, okay. Uh, what kind of signal we get, okay. So you can see that here we assign 0 to 0 volt, okay, for a certain time duration, no? So if we get the time, okay, if we get the time, so this is the first bit, 0 bit. So we assign 0 volt for a certain time duration. Let's say that it is t1 or something. So what is this time duration? It is actually the bit duration, no? This is the bit duration. Or we can call it, it is a pulse duration. Okay, this is the pulse duration. Okay, so here then the second bit also will be 0, so you will assign 0 here. Okay, and the third bit is 1, so you will assign 5 volt for that one. Okay, 5 volt for t1 value. So here this is 2t1. Okay, and here it is 3t1. Okay, so this duration is t1. Okay, so the next one is 0, next one is 1, so on. Okay, so you will get a pulse train like this. Okay, this is a pulse train. This is a pulse train. Okay, so this pulse train is our encoded signal. Okay, so this will be a continuous time signal. You can see it because this t has continuous value, continuous variable, continuous time signal. And also this is a digital signal because we have only 2 amplitude level, only few amplitudes level. Here it is 2. Okay, so this is a digital signal. Okay, so okay, now we have to draw this signal using the MATLAB. So that is our task. Okay, so let's see how to do it. Before that, okay. So I think you have already have the idea how to draw a continuous time signal in MATLAB. Okay, for example, if I take a sinusoidal signal like this, xt is equal to 2 sine let's say that 2t or something, 2t. Okay, so this is a continuous time signal. Okay, this is a continuous time signal, and you want to draw this using MATLAB. Okay, so actually this is if this is the carrier signal. Okay, so it is just like a generating a carrier signal. Okay, so here in your lab exercise you have to generate the carrier signal also. Okay, so that you can use this technique. Okay, so let's see, let's quickly see how we can write this signal. Okay, so first how I think you know how to draw a graph. Okay, so you normally so here we have the independent variable t. Okay, and this xt is our dependent variable. Let's say it is y. Okay, so here we get some value to independent variable, maybe -1, 0, 1, 2, like that. Okay, and we calculate the y. Okay, using this function, you calculate the value for this y. Okay, for relevant t values. Okay, so you will get some value here. Okay, you will get some value here. So normally we draw a signal. Okay, so we get the vertical line as the amplitude y-axis. Okay, the independent variable axis. So here it is xt. Okay, and the horizontal line we get as the independent variable. Here it is t. Okay, then we mark this t value. Okay, -1, 0, 1, 2, like this. Okay, so we will see what are the value for this 0, what are the y value for this x value, t values. Okay, like this. Okay, then what we do, we just join in them. Okay, this is how we normally draw a signal by our hand. Okay, Actually, the same thing we'll do in a MATLAB program also. Okay, so MATLAB will do the same thing. Okay, so it also draw a signal like this using the same procedure. So first we have to define the t value. Okay, so let me define the t value. Okay, so actually this is not the generating the unipolar generating the line coded signal. Here I am going to show you how to generate a normal sinusoidal continuous time signal. Okay, so first we have to define the t value. Okay, so t may be 0. Let's take, I will take t from -1 to 20, sorry, minus 5 to +5 or something, -5 to +5, like this. Okay, like this. Let me run this. Okay, so we will here we are not using this code. Still we are not using this code, so I will remove it from the program. Okay, I just comment there. Okay, so it is not impact, there is no impact to the program. Okay, so if I run this again, okay, so you can see that here we have some value to t. Okay, so if I take that t, okay, so you can see that we have -5, -4, -3, -2, so on. Okay, so this also array, no? This t also array. This t also array, and it has 11 columns. Okay, it has 11 columns. That means 11 values. It contain 11 values. Okay, this t contain 11 values. Okay, so this is another way to define an array. Okay, so we just assign, we just generate an array. Okay, using some integer from minimum value to a maximum value, like this. Okay, so here now so you can directly type your signal here. Okay, equal, what is the signal we get? As I can remember, I take 2 cos 2 sine. Okay, 2 sine 2t, no, 2. Okay, so you can't just write 2t here. You have to put this multiplication sign. Okay, otherwise it will be error. Okay, so 2t. Okay, so now I am going to draw this signal. Okay, I'm going to draw this signal. And 2t sine 2t. Okay, okay. So so now if I run this, you can see that here we have another variable xt. Okay, here we have another variable, and that one also have 11 values. Okay, so what has happened? What has happened here? Can you guess? Okay, so what MATLAB has done is that, okay, so here he have a variable. Okay, he have a array from -5 to +5 with some values. Okay, and here he have so here we have a function with the time variable, and we have assigned into another array, xt array. Okay, so so what this MATLAB doing is that, okay, he first get -5 instead of t, and he calculated this value, and he put that value in this array. Second, he get -4. Okay, and he substitute, the MATLAB substitute the t value here and calculate the calculate that corresponding value and put it in this array again. Okay, likewise, it calculated all the values, all the xt values for this t. Okay, so we have two array with same dimension. Okay, we have two array with same dimension. Okay, so this will generate a array automatically. Okay, so now we have two array with same dimension. Now you can plot this. Okay, so the command is plot. Okay, so you can use this plot command. Okay, so this x is the independent variable and y is the dependent variable. Okay, so here in our program, what is in our function, what is the independent variable? It is t. Okay, so I just put this t, and I just then I have to put the independent variable, that is xt. Okay, so if I get this, okay, I think we have done this earlier. Okay, in signal and system, I think I have done this for you. Okay, so plotting using how to generate continuous time signal using continuous time and discrete time signal using MATLAB. Okay, so I have done it. I think you have gone through that and you are okay with this. Okay, so I will give you a quick recap. Okay, so if I run this, okay, if I run this, okay, you can see that I get the plot. Okay, so you can see that this plot is not a sine wave. Okay, so what is the problem here? What is the problem here? Okay, so actually here you can see that, okay, you can see that, okay, you can see that here we have t minus 5, okay, minus 5, minus 4. No, I can get it. Okay, so we get it to no, like this. Okay, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5. Okay, so you have 11 value. Okay, so you have here 2 sine 2t. Okay, so you substitute minus 5 here and you calculate the value. You substitute minus 4 here, you calculate the value. You substitute minus 5 here, you calculate the value. So on, you have calculated the value. Okay, so what the value you have calculated. Now the MATLAB base going to draw it. Okay, so what he first do, he take the independent variable, okay, and mark it minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, so on. So so he get what is the minus, the value for minus 1, minus 5, and he get the value for minus 4, and he get the value for minus 3. I am just here I am not marking the correct value. Okay, I am just try to illustrate you. Okay, so these value are not correct what I put here. Okay, so he get some value here, get some value here, so on. He marks some value. Okay, then what he doing, he just join this point like this. Okay, okay, so you will get this kind of signal, no? You will get this kind of signal. Okay, so to look this as a continuous wave, what you have to do? Okay, what you have to do? So here you have to choose very approximate point. Here you get your duration is 1, no? Here minus 5, minus 4, so you get 1 step. Okay, okay, but if you get a small duration, okay, so this t will look like a continuous time variable. this t look like a continuous time variable. Okay, so I'm doing this, I get very little step. Okay, so I can do it likewise. In the middle of this two number, I can insert the step. Okay, like this. Okay, so if I run this, okay, now you can see that here we have -5. In previous, we have -4, -5, -4, -3, -2, -1, so on. Okay, so now we have -5, -4.9 because we have 0.001 increment. Okay, so it incremented by from this value. Okay, so you will have the large number of value here. So here you will have 10,001 value. No? So here also you will have 10,000 value. Okay. Okay, now you can see that it is look like a sinusoidal signal. Okay, so this is the way we plot a continuous time signal. Okay, so if you are asked to generate a carrier signal, okay, in this manner you can generate it. Okay, so this is just outline. Okay, and you have to do it with it in accordance with the given task. Okay. Okay. So okay, now we will move to our task. Okay, so this is just explanation, but I think it also somewhat important because you have to generate some sinusoidal signal also when you are doing the lab activities. Okay, and so if you can't remember the way, now I think you can remember it. Okay. Okay, now okay, now what is our problem? Now we have to generate. Okay, we have to generate. Yeah, now we are back in line coded signal. Okay, now we have to generate this signal. We have to generate this signal. Okay, so you can see that here we have only here we have only numbers 0 0 0 1 1 like this 0 0 0 1 0 like this. Okay, so these are just number. Okay, then I have to assign this number to a voltage level and also for a time duration. Okay, so how can I map this value to a voltage level? Okay, voltage level and to a time value. Okay, so that is our problem. No, okay, so there can be many approach. Okay, so there can be many approach. So normally I prefer to do that task, okay, in this way. Okay, in this way. Actually, this is not my own code. Okay, I have found this in Google. Okay, so actually I have used this one to generate a random pulse train normally. Okay, so I think this is a efficient way, and this way has very beneficial if you are if you are if you are going to simulate interference and very importantly, if you are going to deal with interference, this way of generating generating the line coded signal is very much important. Okay, so I'm not going to talk about that in deep. Okay, so I have one comment this. Okay, so this should be okay, so I will explain you how these codes are working. Okay, okay, I will explain you how these codes are working. Okay, so this part I no need, I just remove it. Okay, just remove it. Okay, So now we are going to, I will get the most basic line coding technique, that is unipolar NRZ. So here we normally assign 0 volt for 0 bit and 5 volt for 1 bit. Okay. Uh, okay, we will see. Okay. Okay. So now I am going to do this in this way. Okay. So I will explain how I am going to do this. Okay. And try to understand it. Then you can code. You can write this code in your MATLAB program, and you can observe uh, how uh, how it is working. Okay. Then I think you can get the idea. Okay. So here, so I have 0. Okay. So this is my first bit. Okay. So I need to assign a voltage value here, and also I need to map this into a time period. Okay. So okay. First I forget about the level. Okay. Forget about the level, and I only concern about the time, this time duration. Okay. So this is so I'm going to do this in this way. Okay. First, I take some time value. Okay. So here I have 1, 2, 3, 4, 5 bits. Okay. So here we have 5 bits. Okay. So first I take the time from from 0 to, okay, 0 to 5. Okay. From 0 to 5. Okay. So this will be my time duration. Okay. And I will get the step. Okay. I will get some small step. Okay. Like this. Okay. Increment, small increment. Okay. So here I have generated my time values. Okay. I have generated my time values. Okay. So now if I draw it, okay, if I draw it, okay, so the time value will look like this: 0, 0.001, 0.002, up to 1, okay, up to 1, and 1.001, 1.002, up to 2, okay, up to 2, here it up to 1, here it up to 2, okay, and up to 3, up to 4, up to 5, okay, so on. Okay, so I will have this time value. Okay, time value, this is 1, this is 2, this is 3, this is 4, this is 5. Okay, so now I want to map this 0 to this time value. Okay, so I map this 0 from 0 to 1 up to here. Okay, I map it up to here, the 0 value. Okay, then again I have 0, that 0, this second bit I map, so it may be a 0 or 1. Okay, so I map it from here to here, from this, for this time duration. Okay, and this again the third bit also I have 0, that 0 also I map in this time duration. Then I have 1. Okay, that 1 I will map in this duration, so I will get like this. Okay. Okay. Okay, so this is the thing I am going to do. Okay, then I have then you can see that let's take another array. Okay, so here I have the message array. Okay, so message array, from the message array I am going to generate another array. Okay, so here it is n. Okay, so here it is n. Okay, I'm going to generate another array that is called n. Okay, so I have defined a t value. Okay, that one is also array. Okay, so this is my time array. Okay, so in time array, I have some value 0.001, 002, 003, so on. Okay, up to 1. Okay, then 1.001, 1.002, up to 2. Okay, and up to 3, up to 4, up to 5. Okay, so here I have several time value. Okay, so now I am going to generate another array, n array. Okay, another array using this message signal. Okay, I'm going to generate another array using this message signal. Okay, using this message signal. Okay, and I am going to so here up to 1, there are some values, no, there are some number of values up to 1. Okay, so up to this length. Okay, up to this length actually. Okay, so let's say that here you have n component n or simple n time value from 0 to 1. Okay, 0, 0.01, like this. I think it should be 101 values should be here. Okay, 101 value should be here. Okay, so so I am going to put, so here my bus bit is 0. Okay, so I am going to put 0, 0, 0, 0, 0, 0 up to this length, Okay, so this length will be so maybe it may be 101 elements. Okay, and after that, okay, from 1 to 2 I put this value, whether this may be 1 or 0. In this case it is 0, so I put from 1, that means 1, 0, 0, 1. Okay, 1, 0, 0. So for this value, okay, so there are number of values. Okay, I put this bit, okay, in the same length. Okay, in the same length until 2. Okay, likewise I put the third okay, so this is 1, this is 2, this is 3. Okay, so this is 1, this is 2. Okay, so then I put this third bit. Okay, this bit to 2 to 3 values. Okay, 2 to 3 lengths. Okay, they are let's say that is n length from 2 to 3. N values are there, so I put n values n values of this 0 bit. Okay, so I put 0, 0, 0, 0 up to n values with this duration 2 to 3. Okay, and 3 to 4 I put 1. Okay, so here the bit is 1, and I put 1, 1, 1, 1, 1, 1, 1 up to 4. Okay, 1, 1, 1, 1, 1, 1 up to 4. Okay, so the length, if the length is n, okay, if this length is n, okay, the number of values are n. Okay, here we have number of values n. Okay, and also here I put 1 number of 1 n. Okay, n times number of 1 here. Okay, so I think you clear. Okay, so likewise I generate another array. Okay, so now if you consider this one and this one, okay, so let's say that all point are capital N. So here in this array we have capital N component. Okay, and for this n array also we should have capital N component. So same dimension array. Okay, so now if I plot, okay, this is my independent variable, plot this t, the value of this array. Okay, value of this array with respect to value of this t array. Okay, plot tn. Okay, I will get this kind of a line coding signal. Okay, so I will get 0 here. Okay, 0 again here. Okay, 0 here, 0 here, 0 here, 1, 1, like this. Okay, so I will get this value. Okay, so if you can't understand this, please go through the code then. write the value like this. Okay, one by one you can write the value, then you can understand. Okay, maybe still you couldn't understand what I am talking. Okay, anyway, I am not going to explain it any further. Okay, please try to get the understanding. Okay, so here mm, so here I have already write the terms. Okay, I have already write the terms. So this way we can achieve it. Okay, so there can be different approach. Okay, or maybe your approach may be different from my approach. It is okay. Okay, so this is the my way. Any way. Okay, for this one you can use this code also for generating the NRZ signal. So generating message signal, the line coded message signal, you can use this code, no issue. Okay, because this type of codes are not uh, much available in the internet. Okay, so if you are going to write the code by yourself, okay, then it will take some time actually. Okay, so that you can use this code directly. And I think in your lab sheet also, okay, there should be a so this one. Okay, so this one, I think the same method, no, here also the same method. Okay, so I told you that this is not this is not my own code. Okay, so here I think this in this program, in this code also, the same method is used. Okay, same method is used, I hope. Yeah. Okay, so I think you can use it directly, no issue. Okay, but if you can try to develop another code from yourself by yourself, it may be beneficial, okay, for you. So this is how I get this. Okay, I have defined a variable called s. Okay, that is my step. Okay, so here I put a variable because anytime I can change this step. If it is not suitable, I can change this step. Okay, so anyway, here it is 1 by 100. Okay, so here I define the t here. Okay, I define the t here, 0 to 0 0.001 up to n. What is this n? N is this value, 10. Okay, so n is 10. So what is 10 here? 10 means the number of bits. Okay, so number of bits, you can see that in message signal we have 10 bits. Okay, 1 2 3 4 5 6 7 8 9 10. Okay, so this is the column of the array. Okay, column of the array, number of column of the array. So this n. Okay, so we have n number of n bits. Okay, n number of bits. Okay, so so this t also should be up to n value. Okay, if this is 10, it should be t 0 to 10. Okay, so here instead of 10, we have put the variable. So you can change, if you change the value here, it automatically change everywhere. Okay, so it is very easy. Okay, so I put it up to n. Okay, if you put it up to 10, in this case it will okay. Okay, if you put the number of bits here by counting and puts it here, it is okay, no issue. Okay, so it is n. Okay, and also here we have take 0.001 step. If you write this code, sorry, 0.001 step, if you code this, if you assign this t in this way, it will be okay. Okay, you will get the same result if you run this. Okay, if you put here 10 and if you run this, okay, so because there are many t values, okay, so it will take some time to calculate. Okay, okay, so here the signal is drawn. Okay, so anyway, I want to show you that this t. Okay, so here you have the t variable. Okay, so if you see the t, okay, so you can see that we have 0, 0.01, 0.02, so on. up to up to up to 1, okay, up to 1, okay, up to 1, okay. So you can see that 0 to 1, there should be 101 value, no, 101 value, 101 values, okay. So here from 0 to 1 there is 101 value, then from 1 to 2 uh, uh, in that duration also there should be 101 value, so it should be 202 index, no, up to 2. Okay, so you can see that up to 2, it is 201 value. That means 100 value, no, because there the 0 is also included, no. Okay, so 100 values are there. Okay, 2. And from 2 to 3 there should be another 100 value, 3 to 4 there should be another 100 value. So I have defined my t. Okay, so now what I want to do, okay, so here my so this is my message signal, okay, so this is my message signal in this time, okay. So because when I run this signal, it is generate the signal, the message, it generate a random sequence, okay. So the bit stream can be changed, okay, time to time, okay. So here my first bit is 0. Now I have defined another n array, okay, in another n array, okay, and I have uh, put so let's say that this is my n, okay. So in here I have my n value. So for this point I put 0, for this point up c I put 0, for this point I put 0, for this point I put 0, so on up to 1, okay, up to 1, up to 1 I'm going to put 0, okay. Then so here from 0 to 1, 101 value I put 0, okay. So that is the same value, no. Here also I have 101 value, 0 to 1. Here also I have 101 number of zeros, okay, okay. So here all the for all corresponding time value I put 0, okay. And here my second bit is 1, okay, second bit is 1, so I put 1 here from 1 to 2, okay. Then 2 to 3 I put 0, 3 to 4 I put 1, like so on I put up to 10, okay. Okay, so that is what I'm doing, okay. So this is my approach, okay. So I use a for loop, okay. I use a for loop here, okay. I think you can understand this, okay. So here I change the t, okay. Here I define the t, okay. Then I'm going to run my for loop from 1 to length t. Length t means so here for this t we have 101 values, okay. So here length t will be 101, okay. This length t will be 101. So that is a MATLAB command, okay. You can count the length of any array, okay. So if I type len gth, no, len gth th length of m, okay. Let's say length of m. M means my message signal. So my message signal has 10 values, no, 10 number of values. So this should be 10. The answer should be 10. Okay, so you can see that answer is 10. Okay. So in the same manner, if I see the, so here I have the t value, okay, t value, t array, okay. So if I write the length of t, okay, length of t, I will get 100, 1001. Okay, so here 1001. Okay, so length t will give the number of component here, length of the array, length of that array. So here it will, so here it take 101. Okay, and if you haven't defined any step, any increment like this, okay, always it has one increment. Okay, so if you are not assign any increment here, it will take one increment. Okay, and so if you assign one here, the increment as one, that is also the same. Okay, so here also you can assign the increment. Okay, but you know that using this j, okay, we are going to read a array. Okay, so this j is act as an indice. Okay, so indice should be a integer value. It should be a plus integer value. It can be one, it can't be zero also. It should be one to any value. Okay, so so here j is 1 to 1001. Okay, j is 1 2 3 5 4 4 5 6 7, so on up to 101. Okay, so this j should be an integer greater than or equal to 1. Okay, this is the matrix index, array index. Okay, array index. Okay. Okay, so now here I am going to, so here you can see that I have defined another variable id. Okay, so here I set id as 1. Okay, so now the program is coming to this, so now programming is coming to this loop. Okay, then after it's going to execute this column. Okay, so you can see that there is a if conditional statement. Okay, so now it's going to compare. Okay, so here I write as tj means my t array values. Okay, t array values. Okay, so when it is j is equal to 1, t1, that means this value, the first value. Okay, the first value. Then the j is 2, that means this value. Then the j is 3, that means this value. J is 4, that means this value. Okay, so so now it compare these values with id. Okay, id means 1. Okay, so at the first loop, the MATLAB will check this tj, the number of the value of this t array, value of this the component value of this t array, this value, okay, are less than or equal to 1. Okay, if it is so, okay, this here I have define another new variable, new array nj. Okay, that is n array, and I just equal to mid. That means for my message signal. So you can see that until this loop is running, okay, and as long as tj is less or equal than 1, this id is 1. Okay, so m1 here. Okay, so for this nj value, so that j means 1 2 2 3 4 likewise. Okay, so for all n value, it put m1. That means the first bit of this message signal. Okay, then once the id is the tj is greater than or greater than 2, okay, greater than 1, that is when it equal to 2, it just now it is not it not satisfy this condition, so it jump to this level. Okay, then what it doing? So okay, so this id, this variable is incremented by 1. Now id is 2. Okay, now it is again running here. Okay, it is again running here. Now the id is 2. Now he checking that tj value is greater than, less than or equal to 2. Okay, that means he is running. So in the first loop, he run up to this level. Okay, please try to understand. Okay, I'm not going to I'm going to explain it anymore. Okay, you have to understand it by yourself. Okay, please take some time to understand this. Okay, so here you can see that it is 1. Okay, so up to this level, to up to this level, that means as low the at this level also id is equal to 1. Okay, id is equal to 1 up to that level. For all the uh, array position, it the n will fill the first bit of the message signal. Okay, so in this case it is 0. Okay, and after that, then at this point the id is greater than 1. Okay, at this point id is greater than 1. Now id is 1, not id. Okay, now tj is greater than 1. Okay, tj is greater than 1. So it compare the id with it compare id tj with the id. Okay, this variable. Okay, so now tj is greater than 1. Now it jump to this statement. Now the id, so he increment this id value by 1. Okay, so now id is equal to 2. Okay, now he checking this tj values are less than or equal to 2. Okay, so that means up to here, up to 2, up to 2. Okay, it will put, so nj is equal to mid. Mid is 2, id is 2 now. So nj, j is incrementing. No, j is incrementing 1 2 3 4 likewise. Okay, j is going to increment. Okay, so for that j's position, okay, j's position, that means 1 to 2 position, all these position, the nj will fill the message bit 2. Okay, message bit 2 means this one. This is the second message bit 1. Okay, so for all this location, nj will take n array will fill, the MATLAB will fill one value to the nj, one value to n array. Okay, this array. Okay, so then once the tj reach to 2 at this point, now it is greater than 2 at this point, not this point. This point is also here. For this one also it put the 1. Okay, then when the tj comes to this point 2.01, that means the value is less than, greater than the 2. Okay, then it jumped here, then id again increment to 3. Again this is running. That means 2 to 3 it put values, and j will put values. Okay, so on it will put values. Okay, so you can see that using this is very simple for loop. Okay, you can, I hope you can understand by yourself. Okay, this is your, you can understand this by yourself. Okay, I have given the outlines. Okay, so I think you can understand this by yourself. Okay, so here here you can see that using this for loop, okay, we just we have defined another vector, or another array, that is n. Okay, and we put we map the message bit to that array. Okay, up to from up to this with this time. Okay, with this time up to 1 2 3 so on. Okay, okay, so now this n will have 1001 value, and this t also will have 1001 value. That means this one and this one has a same dimension. Okay, this one and this one has same dimension. So if you plot this So this t is the independent variable, n is the dependent variable, this value. Okay. So if you got this, so here this is for color. Okay. So here you can assign red for that line. Okay. So here you can, if you run this, if you run this, okay, so you can see that we will have this kind of pulse train. So you can see that up to 3000. So here 000, and then it is 1, then again it is 0, then there are 111, 111, okay, and here it is 0, and here it is 0. So I have generate the pulse train. Okay, so this t, so here it is 0 to 1. Okay, so 1, so here what is this bit duration? Okay, so this bit duration is, you can see it is 1. Okay, the bit duration is 1. Okay, but the bit duration will not always be 1. Okay, so that is very important. Okay, the bit duration will not always equal to 1. Okay, so we have this kind of pulse train. Okay, so our bit duration is 1, 1, 2, 3, 4, so on. Okay, so it is not always 1, no. Okay, so this 1, so here it can be a 1 second, 1 microsecond, 50 microsecond, 50 millisecond, anything, this bit duration. Okay, actually this bit duration depend on the bit rate. Okay, this bit duration is depend on the bit rate. If the bit rate is b, okay, the bit rate is equal to 1 by bit duration, tb. Okay, so this tb is directly depend on the bit rate. Okay, this tb is impact to b. Okay, so several system has several so different communication system has uh, different rate. Okay, data rate. Okay, so the different communication will have different TB. Okay, so here you can see that in this case we assign this as 1, 2, 3, 4, so on. Okay, but you can map this one to any value. You can map it to microsecond, you can map it to 20 millisecond. Likewise, you can map it, and then you can count this mapping. Okay, so this is a scaling. Actually, this is just like a time scaling. Okay, so you can do that time scaling, and if you use this time scaling throughout your program, so you will not face a problem. Okay, so you will get the correct simulated result. Okay, so you can map this time, you can scale this time to any value you want. Okay, and I think if you put here, let's say that if I put here 50t, it is also, it will also scale in the time. Okay, so let's take that. If you say that this duration is 5 millisecond. Okay, 5 millisecond. Okay, so if I put 5, okay, if I put 5 here, I think it will give the same result. Let's check. I'm not sure. Anyway, we'll check what happened. So if you can remember the time scaling in signal and system, time manipulating, time transformation, we have learned them, no, time shifting, time reversal. Okay, so this is the way we are doing the time scaling. Okay, so I think yeah, it is working. No? So you can see that now it is 5, 10, 15. So now the bit duration is 5 here. Okay, okay. Actually, this one now I figure out. Okay. Anyway, it is working, no? Yeah. So you can see that here you can assign directly here. So this if this 5 is a 5 millisecond, and I think you can directly put it here. If you put the millisecond here, so that means 10 to the power 10 to the power minus 3. No, if you put this value here, okay. Anyway, for the safety, I will put the bracket here. Okay. Okay. Yeah, now it is okay. No, so this is 0.005. That means 5 milli. So you can map it to second. Okay, it should be millisecond. Again, you have to do a mapping. Okay, you have to keep remember this. Okay, and you can do so when if you want to say 5 seconds. Okay, then here you have to directly you can put 5. Okay, if you didn't put this value, and if you think this is 5 millisecond, okay, if you want to show 5 seconds, you have to write, you have to type 5,000. Okay, likewise, if you can remember your mapping, you can do it. Okay. So I think that is enough. Okay, so here you can see that we have we have assigned this value to 1. Okay, the voltage level 1. Okay, not 5. Okay, but very so if you very easily we can scale it to 5. If you multiply this m value by 5, so I think it will be okay. It will be up to 5. Okay, let's check it. Okay. Let's see. I hope it also will work, because you can see it is very simple. Definitely now, if the MID M1 is 0, 5 into 0, 0. Okay. Okay, now it is 5 volt. No? Okay, likewise you can do this. Okay. So this is NRZ. So if you want to NRZ unipolar, that means let's say that plus 1 is plus 5, minus the 1 is plus 5 and 0 is minus 5. Okay, so you can do it very easily. Okay. uh, uh, Actually here also you can use if condition. Okay, if condition, and you can say that if MID is equal to 1, NJ should be 5. Okay, NJ should be 5. Okay, if MID is so I will write it. Okay, so otherwise you can't understand it. Okay, very simply you can do it, I think. Okay, let's see. Okay, so here I use another if. Okay, if condition. Okay, so under this if I use another if. Okay. So here uh, if MID, okay, MID equal. So in the statement you have to put two equal sign. Okay, equal to 1. Okay, equal to 1. Okay, then NJ, okay, NJ should be 5. Okay, NJ should be 5. Else, okay, else means if mid equal to 1, okay, else means m has only 1 and 0. So then if it is if it is not 1, it should be 0. Okay, so you can directly write here nj should be -5. Okay, -5. Okay, so you have if else here. Okay, so this one you have to end. Okay, so if I write end here, then it is okay. So I think it is okay. Now I think we can get the bipolar NRZ signal. Okay, no. Now you can see that. So you can see that now 0, 0. That means -5, -5. Then 1, that means +5. Again 1, +5. Then 0, -5. So I am looking at this bit stream. Okay, I'm looking at this bit stream and compare this bit stream with my signal. Okay, with my line coded signal. Okay, so here you have 1, 0, 0. That means 0, 0. -5, -5. Here you have 1, +5. Again you have 1, +5. You have 0, 0, 0, -5, -5, -5. So I get signal. No? Okay. So I think you can generate a reset signal also. What you have to do is you have to carefully you can use this kind of if and condition. You can carefully assign it. Okay. So try to generate a reset signal as exercise if you want. Okay, then you can get the full understanding. Okay. Okay, so now I think we are okay with our message signal generation. Message signal generation means the line coded generating a line coded signal. Okay, so we will go to the next step. Okay,